And now hello YouTube as well, because I double stream to YouTube and Twitch. But for live chat, go to Twitch. I only read Twitch. As always, my phone reminded me that I'm going live. I need to turn off those notifications. On Errichto, on Twitch, the name is preparing for Facebook Hacker Cup. That's wrong. Also, it's not that I'm doing something private right now. What are we doing today? I will copy the name from this. Playing programming videos. And Gaussian elimination. But first the today command of Nightbot, no, stream elements. Stream elements. Can I click you? Login Twitch. Yeah. Maybe I will check if I type FAQ who answers me. Yes, stream elements. That's my bot. Dashboard bot. Chat comments. I'm here. Today. There is no today by default. Twitch is today the best command because I'm a bit stupid and I always kept modifying this description below the stream, but I think chat is more convenient. So what do you want to be the command that explains what I'm doing today? Should that be exclamation mark today? Right now we have, for example, help, FAQ, job. I think we have help. Don't we? Oh, strange. But there is FAQ here, right? Oh, custom comments. Yeah. Okay, those are my custom comments. There's YouTube. I should create YouTube too, I guess. And after I'm done with this, I will work on Gaussian elimination. Is today fine? I need to reorganize a little bit. This goes to second monitor. Good morning, everybody. Mustafa, Luste. Just remember that I will focus on Twitch chat. Make a video on segment 3. Chat, live chat is not a good place to make a suggestion because I will forget. Write that in my Discord server or as a comment below my YouTube videos. Hello. Now I'm removing this. Should I completely remove that? Maybe? Yeah, I'm going to do that. New Discord server. I will move it here. Let's see how this looks now. Yeah, it's fine. Also, I currently don't use this. Is that configure? Once I stream regularly, maybe I should... I don't know. This schedule is messed up anyway. Geometry lectures. Oh yeah, segment trees are on Codeforces Edu. At least here I'm red. For me, you are now orange. Sorry about that. Okay, so today command, and then we move to Gaussian elimination. Will I need to modify it every day though? I don't know if that's the most convenient thing for me. Global cooldown, user cooldown, so that's by default. Chat, Twitch chat, can you try now? Exclamation mark today. Mainly going for Gaussian elimination problems to prepare a YouTube lecture about that topic. Cool. Then I think it's good to people do something like that. Should I remove this actually? There should be help maybe. I don't think that comments is the best one. I didn't know that it should be comments. I think that exclamation mark help should do that. But maybe I will get back to it later. Now I'm going to work on Gaussian elimination thing. And I have a list of such problems. I need to find it. I know where it is. Give me a minute. It's a list of problems I used for some Polish camp or whatever. So the problems are in Polish. Some problems are in Polish. Gauss. Yeah, found it. It's from February of 2019. And it seems that mostly problems are... Whoa. Oh, it works. I thought that there is some old link and the problem isn't there anymore. So the problems are mainly links to English contests. They are free in Polish. I will translate them now. And I need to choose some of those and maybe some others to make a good lecture out of them. To teach people about Gaussian elimination and about just using it in competitive programming. I think that CP algorithms, they have something about Gaussian elimination. I know where I will find it. In resources. Okay. Once I went through the internet to find good resources on Gaussian elimination, and on Wikipedia they explained an example, and on CP algorithms they explained what it means for us programmers. Stop suggesting things in the chat, I will not remember it. Go to my any of my YouTube videos, post it as a comment. If other people agree with you, they will upvote your comment and I will see that people like that. Twitch chat is not a good place to suggest a new video. How to find a link? Oh, I'm working on it now to prepare it into a nice lecture. You don't need to do anything now. Just wait until I prepare it. Now, where is this? Because this is PDF. Overleaf. I mainly prepare such materials in Overleaf. And that's Gaussian elimination. Yep. Found it. I have some .tex file, and I can easily translate it to English now. Maybe I want to copy it. The date is changed now. I've been waiting for this one, for Gaussian elimination. Yeah, for a lot of things there aren't very good materials online. In particular, there is no good video. Recently, somebody asked me about a tutorial on trie and like the structure for strings, TRIE. And that person said that in the internet it's very hard to find any good article, and I indeed googled trie tutorial or trie explanation, and there are some articles, like one on HackerEarth, one on some other random website, but I'm surprised that it isn't, for example, explained in Codeforces. What happened to the Discord channel? See description of... Oh, I should add that to comments. Wait a second. On Twitch, if you scroll down in description, there is a link. But also... chat commands, add new command. Discord, do you want Discord or DS? New Discord server about programming. For people watching me. Is that a proper description? New Discord server for people watching my videos and streams to hang out with me and talk about It's not only for competitive programming, it's mainly for competitive programming. For my viewers to hang out with me and talk mainly about my new mainly programming Discord server for my viewers to hang out with me. Yeah, fine, activate. Okay, we have exclamation mark Discord. I don't accept donations, no. I would keep it short. So you think that the description is here to say, to inform you in what case you should be interested in joining the server. But yeah, I think you're right, Suraj, that it's too long. Let's just keep it like that, plus maybe 3-4 words. Not even donations in C++ code. I don't need any C++ code from you. Just this. We have this stupid name of Errichto server official. I didn't choose the name. I chose a name Errichto to the name, and then one of my moderators made Errichto server official, and it's fine. But I don't know. Oh no, I don't want to tag myself. Yeah, just this. People will understand. Yeah, giant killers, stop repeating the same comment. Donations in rakia? That rakia is a very fine alcoholic beverage. Back to this. So I can put this XOR, not XOR, elimination Gauss contest in Codeforces edu section. Mike said that he will happily take me on board to on the edu section. They can even help me with preparing problems. Because this is not a good first problem for Gaussian elimination. If you are to learn Gaussian elimination, none of those problems is good. Let's see what, actually let's read the first problem from the list. Given a set of integers, compute the maximum XOR of subset of numbers. That's the first problem. And the sample is just stupid, where we take all the numbers. No, instead, the first problem on Gaussian elimination should be you're given a set of equations, find any solution, or check if there are 0 solutions, 1 or infinite number of them. So let's work on a better set of problems And to make it public, why not? Let's go to GitHub. My GitHub wiki, I don't know, current notes. What do I have here? DP lecture. I can remove that. These were one. I don't know if I want to remove it. I kind of want to move this to archive. But new thing. Maybe before I start saying it 100 times, how do you pronounce Gaussian elimination?
Gaussian elimination.
Gaussian elimination, not sh, s.
Gaussian elimination.
Remind me if when I say it wrong. The same happened for matrix exponentiation, because all the time I say matrix exponentiation. I don't even remember now. I think it should be exponentiation. Exponentation. Oh yeah, I say exponentation. It should be exponentiation. Gaussian elimination. That's an official name. No, I didn't want to show that. But there was nothing private here. I need to remember to close Facebook after getting something from Facebook. What I wanted is overleaf, so this website, I will just copy it. So this is good for the first problem about Bitwise XOR. How do you put something in form of link but then description? Description, link. Yes. But I actually prefer this. It will be easier to see the full link and copy it if necessary. In a moment you will be able to see this website. Snake and ladders. This is one about a board game where you will go up through a ladder or down with a snake. Save page. So you can already access this if you want. I'm pasting in Twitch chat. Better make a gym contest? Well, Code Forces Edu is kind of a gym contest. How is gym better than Edu? Because Edu is a video, article, and problems. Gym is just about problems. And it's more difficult to find it. Yeah, it's a common name, snakes and ladders. So if you're saying that Dream is better for some reason, then explain it to me. And YouTube chat, don't try to use exclamation mark Discord. As I warn even in the title of the YouTube stream, I only support the Twitch chat. Let's translate this next problem. Given a small directed graph. We start at vertex 1. Every move is we use random edge going out of the current vertex. Find the expected value. I'm translating from Polish from this thing. Of number of moves before we get to the last vertex. And 100 is too much. This couldn't be a competition problem because of precision issues. Maybe it will be fine for 50. Next. Oh yeah. The next problem is simplification of topcoder 1. A sequence of n integers. There are two players. I have Adam and Bartek, but it would be nice to make it more English. What does we say in English? It's Alice and Bob, right? Alice removes some numbers. There are two players. First, Alice removes some numbers, then Bob removes some of the remaining numbers. But can't remove everything. Then they play Nim. In English, do we say Nim or Nimber? No, Nim. Then they play Nim game. Alice starts. How many numbers at least should Alice remove in order to ensure the victory in Nim game? So in other words, Alice should leave a set of numbers such that no subset has XOR equal to 0. Now the last problem is same, but every number has a price. Same problem, but every number has a price of removing. Pi. And the last one. Okay, we are done with making this English. But we're not done with finding good problems, because these problems are too advanced. When is Hacker Cup final? I don't know. It's not announced yet. Most likely in around 2, maybe 4 months. Did I say before? Yeah, before our precision issues. Thank you to the section. Sorry, when I'm busy, I don't follow the chat, like, you know, every second. Sometimes I need to get back to something after a few minutes. How about how to prepare for IOI using Java? Solve problems from Olympiad competitions. You're welcome. And use Java. "69 viewers, nice. Can you send the link again?" Sure, but you can, in description there is my, actually, is there exclamation mark wiki? No, then let's make it. Stream elements, wiki. No, I don't want to modify this. New command, wiki. Okay, now you can type wiki. It will lead you to my GitHub wiki, and in particular, I'm doing Gaussian elimination here. But for your convenience, you can type, let's say, Gauss, and I will give you an exact link. But I will remove this comment later. Fuck Java, all my homies hate Java. Yeah, that's a good reason not to like a language. The first try in chat I see we have GUAS. More like gulag, I guess. GUAS. It's Gauss. G-A-U. Yeah. Okay. What easy problems do we need? Let me see CP algorithms. So these are resources, good resources I found months ago. Given a system of n linear algebraic equations with m unknowns, you're asked to solve the system. The algorithm is this. I thought it's a link because it's blue. Sequential elimination. Without this heuristic of choosing the biggest value, even for matrices of size about 20, the error will be too big and cause overflow for floating points they test in C++. I believe that. It's very important to choose the biggest value, the maximum absolute value of A. Do they actually swap? I never swap in my implementation. Because just many times we need to get some information about every line and then we need to keep track of where every line is. Oh, I guess this is where. I prefer my new matrix to be more chaotic, but still I can understand what happens there. Do you think that William will win IOI? If exactly one person wins, then he has like 10%, but maybe there will be tie on the second day. I don't know when is 1v1 battle. Sorry. Maybe I will stream some video games, I don't know. Will I solve the problems? The point of the lecture will be to teach everybody how to solve those problems. It's not that I will go through them now. The solution for, let's say, problem number 2, number 3, number 4, actually I should now look here. The solutions is just make a system of equations for expected value and then apply Gaussian elimination. Why is this not? Wait. I don't have LaTeX here? Really? Plugins? Oh. Why did I think that I can use LaTeX here? Why do you keep asking about Java? I told you, practice problems, use Java. You got timeout. Anyway, here it's quite obvious what happens. Just N and AI are up to this. Let's make it up to 50. These constraints are already dangerous for precision. Let's do it like this. Seems better now. What should be the very first problem? Given a system of equations, or maybe just two equations, maybe you're given a system of equations with exactly one solution. Find that solution. But anyway, you need to implement the full Gaussian elimination. What's the easiest problem here I can use? Two equations is quite easy indeed, but maybe it's fine to first give such a problem that you can solve it by hand. Also, unrelated thing is I need to grab something to eat because I didn't eat breakfast. You can access this page in Twitch by typing !Gauss if you want to read the problems or something. I will be back in a minute. There is some cooldown of this function. You won't be able to use it every second. Marco, I will not now jump to another problem. I'm working on something here. What do people in Poland? Food? It's hard to answer. You should Google that. JSK, please don't stream when I have lectures in my uni. Sorry about that. My bad. So, solve a system of two equations. It would be very bad to use a problem here with precision issues. How do you check if solution is good? I think this is a good start, where we kind of guarantee that maybe even this, n equations and n variables, okay. I like this idea of one solution. I will not give a problem of two equations, because what's the point in solving that with some, formula? Now, solve a system of n equations and n variables, and it's guaranteed that there is exactly one solution. Same, but n equations m variables. Say if there are 0, 1, or infinite, or there's infinitely many solutions without providing one. I don't want to care with precision errors too much. It's already enough that here we do that in the first point. Right. Oh, I guess I should go to Twitch to see it, because, oh yeah, I see. Thank you, Tawons. You like Gaussian elimination? Let's see what food is good for CP. No, it's not good for CP. I just quickly made a toast. So here you go. My background is magnificent. Thank you. No, we see part of non-background. This is going to be Discord emoji. What? Meeting? Nah. Thank you a lot for a raid. We are doing competitive programming mainly on this channel, some algorithms. Today I work on problems for Gaussian elimination lecture I will prepare, because on my YouTube channel I have like videos, for example, about dynamic programming, a lecture with several problems. Or recently it was for matrix and exponentiation. What a difficult word. Original Discord server still exists, but I only had a channel there, and that server is kind of dead. Okay, and answer accepted if error, absolute relative error at most this or something. And I guess that n will not be big because of that. Up to 50. Aij up to 50 as well. And similar conditions here. So this, that, and what about binary Gaussian elimination? We have all those problems online, but really, Snakes and Ladders and Charlie and Chocolate Factory, they are just one step after this. I think this problem should be earlier. Let's see. Oh no, not before that. But let me reread those two. This is a problem with modulo, and this is a problem with precision. What are the limits? And the grid is up to 12 by 12, so the number of variables here will be 100. I'm already not sure if this problem can always be solved with good enough precision, because we have a grid of size 144. That this is the number of cells, so the number of variables. Every snake, every ladder gives another equation, and every cell also gives another equation, I think. No, the relative or absolute or whatever difference allowed is here 10 to minus 2 instead of the standard 10 to minus 9. You can guess from this how bad Gaussian elimination can be, how big precision errors we might get. So I will not have this in my lecture, it's just an additional problem if somebody wants to solve it, because it's quite stupid. Then Charlie and Chocolate Factory, this is also quite stupid. But if I want to make all of that educational, then I should have a simple problem for doing this with real values, then also doing this for binary numbers and for modulo. Here, I don't know, find any solution. Okay, something, and then a bonus will be this. Does this involve matrix exponentiation? If yes, then maybe it's not a stupid problem. We have 100 cells, we move one by one. Wait. Isn't it just matrix exponentiation? I don't know what is TCS code Vita. No. Another good top-coder problem about it. I will take a look. That's not a statement. Sum of XOR. That's not a statement. Well, give me a statement and then I will take a look. There are a lot of belts, each of them has n up to 100 cells. The first generates second and so on. This seems to be just matrix exponentiation. You pronounced it correctly, thank you. Wait. So now I see this in a chat. And isn't this... Yeah, okay. It will be very hard to rickroll me now, because I know the three last letters of rickroll link. It's XCQ. Almost like the XQC guy, streamer. So catalyzer, not today. And cards, number xi, 2 bugs. XOR of all numbers is this and that. Your goal is to find the maximum value of S1 plus S2. It's something like, won't it be try? So first of all, we want, is this try or Gaussian elimination? For the most significant bit, I want, if there is even number of numbers with 1, if numbers are, let's say, like that, I look at the most significant bit. If there are, let's say, 6 numbers with this one, with this bit, then I want to split them into groups like 1, 5, 3, 3, or 5, 1, so that in each group the XOR of them would have this bit on. if there are 5 numbers with this bit, let's call it this bit, then no matter what I will do, one group will have this bit on, the other one will not. Then for every number let's say there is variable AI equal to 0 or 1. Say if we take it to second back. Then we will have something like I think that's the equation we will get if we want among those 4 numbers, number with ID 2, 4, 5 and 10. I want odd number of them to be in the second back. Then this is kind of condition we have. Each of them is 0 or 1, and we will just ask if there is a solution to this system of equations. If I understood everything correctly, that's a very good problem. I like it. I don't see any disagreement with me in the chat. Okay, I like the problem. Though this is example of a problem I cannot use in Codeforces Gym, because this problem belongs to topcoder. It's not legal to just redo it and put in Codeforces. But I can obviously put a link. Though it's so difficult to upsolve in topcoder. Maybe I can ask topcoder, hey, can I redo your problem, put it in Codeforces, and I will put a link, curiosity of topcoder, and here's the link to the original problem. Maybe they will agree for that, but I'm not sure. No, for them Codeforces is, well, a competitor. If somebody in the chat can read from lips, then you can tell me what I was talking about. Thank you, Douche17, for the link. It is a cool problem. It's called sum of XOR. Is this problem the best binary thing we can have? And can I steal problems from from SPOI without asking? Beware, input is not formatted as described. It cost me 3 wrong answers. Basically, I don't like the idea of linking to this problem because sample is so bad. In educational problems, samples should be very strong to help people. In particular, if we have this problem, solve a system of n equations, I think I will put like 4 samples and one of them will be not very small, and I will exactly say in sample explanation how Gaussian elimination will work, or it will be in the lecture. He just called H. Mehta. Yeah, he called me saying, "What are you doing? Trying to steal problems from Topcoder? No way." Is this Gauss? If not, then I'm not going to look at the problem now. So this is okay. Did we agree that those are matrices, not Gauss? Why do I have that in my list of Gauss elimination problems? Okay, I'm removing. Maybe it's my bad, maybe I don't understand how it's Gauss. Pachinko from 2014 ICPC finals. Thank you, Snapdragon. But if it was a difficult problem, then the only possibility for my lecture is that will be like the last link. Instead of thinking how difficult the problem is, I will find the standings. Too hard to give us an example, I think. Yeah. Are there detailed leaderboards of past years? That's the last year. Maybe I can modify the link a little bit to get that. Not on the official site. Okay, anyway, I believe you that this is a difficult problem then. Instead of, should I read it? I think it doesn't even matter if I now solve it in 5 minutes or in half an hour, so I will not even read it. Sorry, but it will say hard problem suggested by Snapdragon. And later I will consider to put a link at the end of the article or whatever I will create out of that. I need to also read this. Let's actually read this. I don't remember if it's educational, if it's difficult. Was it maybe segment tree of something? I think, yeah, I remember. It was a segment tree of, how is it called? A linear base. In every node of a segment tree, we kept up to 30 or 20 values. Okay, this problem says find a base of interval of numbers, and I see two possibilities of how to solve it. Either it will be a segment tree. Every node will keep those 20 numbers because 20 is logarithm of this, or maybe it's kind of two pointers, because for every starting, as a preprocessing, for every starting point, we can say that if we reach further and further to the right, then what will be base, and the base will change only logarithmically many times. Those are two solutions. I wonder if tutorials describe them both. It's called basis, not base, apparently. I don't know English names for everything in algebra. Oh, they use divide and conquer. Divide and conquer is equivalent to a segment tree. This problem is similar to this. Do I have this problem? Create a segment tree on the array. Code for reference. It's cool that there is code, you can read it. Okay, great. This is a nice problem. A nice difficult problem on Gaussian elimination. Just question is, do I have this? Yes, I do. It's 0 XOR subset. Well, it should be 0 XOR subset less, whatever. Okay. Maybe those two should be one after the other. Not sure. Do I sound German to you? Oh. Like the comment. Preparing those lectures on anything, it takes so much time, because if I want to make a good article / lecture / set of problems, I need to read this. And it will take me 15 minutes to go through those problems. At least 15 minutes. Ugh. Romanian, maybe. I'm reading the blog, so sorry, it will be quite boring. Until now there is nothing technical. Please be patient, stuff like that. Okay. Problems that can be solved, this might be valuable. Problems that can be solved using this technique are actually not that much hard to identify. The most common scenario involves you will be given an array of numbers and then the problem asks for an answer by considering all the XOR sums of the numbers in all possible subsets of the array. This technique can also be used in some online query problems. Can we remove numbers? Can we do anything about that? We can with a segment tree. Yeah, so in Polylog it is possible to remove numbers. And maybe that's a good problem. Handle queries, insert a new number from 0 to billion, or maybe million is better. Remove a number, insert a number, and after every operation say what's the basis size. This is equivalent to asking about the number of possible XORs we can get. Yeah, I like the idea of this problem. I will add it. If I didn't get the idea during this stream, I would put it in Codeforce's educational contest. Maybe. Well, whatever. Process queries of two types. Insert and remove element X. Print basis size after every update. Those are more updates rather than queries. Okay. This will be O of n times polylog. So it's what? Log cubic or square? There's single logarithm coming from a segment tree, or whatever divide and conquer you use. Merge of two nodes of a segment tree takes quadratic time. So I think it's cubic. I usually don't put nodes like this one in a list of problems, because if you now look at this list of problems, the problem is completely spoiled for you, but this one is just not trivial, so I prefer to do it. I don't have plans to make a course on Udemy, and I will not just now switch from what I'm doing to solving a random problem you suggest in the chat, because then I would not be able to do anything during this stream. Maybe actually in Markdown it is possible to hide it. details. But I think it will break the formatting of like the bullet list. Yeah. Done. Abu, you get a timeout. I already said that. No, I will not say. I will not now abandon what I'm doing and solve a random problem. Is this Gauss? The question was. I don't know, the statement seems long. I don't need more problems unless you know that it's a valuable, interesting problem. What? Is this Gauss? But again, from now on, well, still, I'm not solving unrelated problems you're suggesting in the chat, but if you have something that you know is an interesting Gaussian elimination problem, then you can suggest it. Like, oh, I need to continue reading this. The whole technique can be divided into two main parts. Some problems can even be solved using only the first part. Represent each given number in its binary form and consider it as a vector in that space. I don't like all those blocks that explain Gaussian elimination with algebra, like vectors in space, because we don't need any of that to solve it. Or maybe we don't need to understand algebra to solve a system of equations, because we just know how to subtract two equations. Maybe we need that for binary Gauss, to understand that the space is spanned by those vectors. So I think the technique is just Gaussian elimination. During my lecture, I'm not going to explain anything with, or should I? Should I explain things with multi-dimensions? I think no. Maybe I will just mention it. I will mention, actually, this is related to representing points in n dimensions, or m dimensions, number of variables, but we won't worry about it, because there we just care about kind of collinearity of points, or them being coplanar. Square subsets. Number of different ways to extract non-empty subset of elements. Their product is equal to a square of some integer. So we care about divisibility by primes. The number of primes up to 70 is around 20, maybe 15. Okay, cool. I like the problem. Wait. Square of some integer. Do we really need dp for that? We apply Gaussian elimination on a matrix. And then we just use size of the basis, don't we? Hard to visualize n-dimensional spaces. Yes, but you can visualize 2 dimensions and 3 dimensions, and that should be enough. I'm able to explain to people what it means that 3 points are coplanar with 0, 0 in 3 dimensions. We put a plane through 2 points and we see if this third point is coplanar with them, or just we can also explain linear combination or just combination of 2 vectors by making I guess I would explain it like that, but I'm not claiming that it's extremely easy. If we have this vector possible and this one, and we can, starting from 0, 0, if we can move by that much, or we can move by that much, and also we can move by any part of it, so it's allowed to take a move by 3 minus 1 half. Those are our 2 possible moves. Then can we ever get from 0, 0 to point this? I don't know, I'm just taking random numbers, so likely we cannot here. But that's explanation in 3D. I mean, this explanation works for more dimensions, because you can put more dimensions, just that for 3 dimensions we can also visualize that in some way. But do you really need it? Do you really need any of that to solve Gaussian elimination problems? I think you don't. Maybe it's easy for me to say that because I already understand what the basis is. In all those problems about bits, you find basis, and will people understand why they are doing it? For bits, I would say that we remove a number if it's possible to get it as XOR of other numbers. For non-bit related problems, we usually solve a system of equations to get a solution for that system of equations and take some number out of this solution, like expected number of moves. So only for bit related problems we need to say about basis. I have interview next week. Any tips? For Amazon, you need to read through Amazon values. Amazon interviews involve asking you important behavioral questions. So that's my tip for you. He's saying, what if the constraint was much bigger, say 100,000? I thought that the constraint is 100,000. If AI is up to 100,000, then I don't know how to solve the problem. Because every number is related to, or maybe I need to read the solution. The constraint was 70 on range of numbers. But if this is big, then our masks get very big. And I can then solve it in polynomial time. N times this value, maybe squared. Let's read the solution. "19 primes up to 70. Yeah. DP position mask. The actual number of different possible AI is just this. Where this is the number of ways to select even number of elements. Yeah, fine. Does he get back to this problem after introducing vector basis? Very strange. Talking about dimensions, BSIO has had very hard third problem recently. Oh yeah. Wait. I think binarysearch.com, is that it? If I'm not mistaken. This website is in my to-do to practice, to write a contest there. Actually, there is one tomorrow. I saw one day. It slightly collides with Kochev Cook-Off. I will participate in it if I quickly finish Cook-Off. Yes, I will add that to my calendar. half an hour collision. Yeah, exactly. If it was the other way around, it would be fine, because I'm guessing that binary search contests are usually easy. Doesn't? No, I think there is a collision. But that being said, cook-off is on Sunday. Oh, so I have another collision. Okay, maybe I will participate in this thing tomorrow. But I'm not going to see a problem unless it was Gaussian elimination and it's interesting. Does anybody confirm in the chat that this problem we're solving here, the point is that we can avoid the P by just running Gauss on those bit masks we found? So we create numbers of length 20. There will be only 70 different numbers there. But if we make this bigger, the problem becomes like the solution becomes slow, because numbers get very long. And good morning, Harry. So far I like the blog. I think it's too technical. My lecture will not be that technical, that mathy. But I don't see the point of this first problem. Also, I need to think, do I remember why this works? Yeah, I will run Gini. There is this very easy way to implement binary Gaussian elimination. Where if we add element x, we just iterate over existing value in base, and we do this. That's the whole implementation, but it isn't trivial why this works and why we shouldn't go kind of column by column. What do we do here and in what order? After I put a first string like this thing, later what happens if I have this x, it will not be XORed with this. Even if I have this, it will not be XORed with that, and it seems suspicious. What happens later? I can also have something longer. If I get this value, it will be XORed with this, and then this bit will be fixed as well. So I know that for any new string, any new binary number, this will be 0, and because of that this will be 0. So if this first one I denote as something special, let's call it S, then I know that everything below S's is 0, so I will not mess up a number. And now when I have anything new, then for sure below S's I will have zeros. And just if there is any 1 remaining here, maybe this is the first one, on the left there were zeros. It's okay that I don't go through numbers above to make those 0, though I could. And I would not mess them up, because below S's, even if there is something like that. Even if this S is on the right from 1, I know that this is 0 here, so I will not mess up this number by XORing with U. The answer will be something like 2 primes minus size of independent basis, right? Yes. But it's, you mean this problem, right? The first problem. Yes, but for the size of linear basis, we need to run Gaussian elimination, and it will be in complexity n times number of primes, so this divided by log, times one more dimension, I don't remember which one. So to slow, if numbers are big. I see constraints for which this DP solution is too slow and Gaussian elimination will be good. If AI is up to 500, then the number of primes will be around 50, and we will have complexity n50 square. Actually n50, because bitwise Gaussian elimination doesn't have divides by 32. Binary operations are very fast. Yes, and you're saying this is called pivotless Gaussian elimination. You know, we don't really care. It's not that Gaussian elimination really cares which bit is leftmost. Gaussian elimination, if you permute the columns, Gaussian elimination will give you the same solution at the end, just permuted. So the size of linear basis is the same. It's very standard, and this is what you would be taught at school, to go from left to right, because it's less chaotic. And for a program, if you use bits, then you save several lines of code this way. Maybe you lose a little bit of order. By order, I mean it's more difficult to understand from what we have at the end what really happened in the process. I don't know. But pivot is to choose the biggest element of a column. By pivotless Gaussian elimination, I would understand that for every next column, but still going from left to right, we just take the topmost available number. By pivot, I just understand taking the maximum value in a column. The thing fixing precision if we operate with real values. So I don't understand this name for the technique. I tried two different problems, like I will refer to this comment. Tried two different problems, like find maximum XOR of pair of numbers and find minimum XOR. Isn't this more like try? Where we go from... Actually, in both cases, I would say that we go from the most significant bit of subset. Okay. Yeah, for a subset, min and max subset, what about this? We find this linear base even using my method. We sort numbers from biggest to smallest, and then we greedily take them. That will give us max. What about min? We have a condition of at least one element, right? Otherwise, we just take empty subset. It needs to be sorted, but the algorithm automatically sorts them in decreasing order. If you talk about this, no, my linear basis isn't sorted. After number 100, there can be a bigger number. And there can be smaller, obviously. If you start elimination from lowest bit, then you get minimum. Like, you need to run Gaussian elimination from... Basically, this... Maybe this is symmetrical to something. No, never mind. I wanted to say that we flip every bit and then it will be the same as maximizing. Yeah. So just, I never said that this algorithm is easy to understand. It's tricky why this works. It's only true what I said out loud, that after we have some special bit, the leftmost thing, below that there will be all zeros. So now, this is important. If I hit here at shuffle, the algorithm doesn't work anymore. I strongly rely on this particular order I have. It's just that on some position, like let's say this one, maybe my next number x to be added, maybe it will be XORed with that, maybe not, I don't know. Obviously, this operation, x is minimum of x and XOR with existing, it just means if x has 1 here, then apply the XOR. So we don't know what happens with other columns. We never checked it. This is equivalent to if x and most significant bit of existing x XOR existing. That's the same. But after something happens with a column, eventually we get a special maybe bit here. After that there will be all zeros. And at this moment it's fixed. This is a proof why below zeros we forever get zeros. After we apply that, x has 0 at every special position. And if x is not 0, just means we have some new position, and this position is leftmost just because of how this works. XORing with existing and taking minimum is equivalent to checking the most significant bit that is on. So here, by this, we kind of also mark S of most significant of S. Mark this as special column already taken in Gauss. Okay, mean subset. Do I understand mean subset? You're saying we go in Gaussian elimination from right to left? Find non-empty subset of numbers with smallest XOR. Let's solve this problem. I don't know right now how to solve it. Gupta, do you have a source, any link to this problem? Why won't this be the smallest element in linear basis? It will be. It will be the smallest element in linear basis. Because the idea of linear basis is that those are some numbers, let's say b1, b2, b3, 4, and they give you 2 to k power. Here we have 2 to k minus 1, non-empty subsets. We have 2 to k minus 1 non-empty subsets, and for each of them we have some most significant bit. And if we take b1, if we take some subset of those, and they are sorted decreasingly, so this has the biggest, most significant bit, this bit will be on. Nothing smaller can turn that off. And this is a proof why it's stupid to take u. By removing u, I'm only making a smaller thing. So the smallest element of linear basis is the smallest possible XOR. This also means that no matter how you find a linear basis, the smallest element will be the same. And I'm very surprised. Catalyzer gives me some link to YouTube. I need to get mail. Catalyzer gives me some link to YouTube, and I bet that it's Rickroll or something equivalent. 1 second. I'm so surprised about this observation. No matter how you choose linear basis, the smallest element in linear basis must be the same. Seems crazy. Earlier I see, what if we swap meanings of 0 and 1 and solve for max? Yeah, I already considered that. It's bad because it's important that empty subset gives XOR 0. If you flip the meaning of 0 and 1, you mess up what non-empty subset, what empty subset means. But wait, this doesn't apply to any possible basis. Let's see. Oh yeah, okay, good point. So for the past 5 minutes, apparently I was talking about more standardized. Is that a word? Standardized linear basis, where if you have a number with some most significant bit, no other number has that bit on. So, okay, now I understand. My base doesn't satisfy that. I need to fix my base later to find the minimum value. What I said here about basis is true only if by taking a subset, if I look at your most significant bit, nothing later has the same bit on. I wonder if this will work. Sort my base and then wait, so this sorts increasingly. Going from smallest values, so after sorting by most significant bit, try to make numbers smaller and smaller. It will not work if we go in the other order, because it's bad to start with a huge number, because maybe you never can cancel it. You might be stuck there. But if numbers are so messed up, then this base of 0, maybe it means nothing. Maybe everything has 1 on the first position. Is that possible? In my base, below a special S, there are only zeros. So what I need is called basis reduction. Thank you. I cannot get 101 and 100, but I bet that I can get something similar. Consider this. Wait. For me, no two numbers have the same most significant bit. My lemma was correct. I only use this fact. No two numbers have the same most significant bit. If that's true, then, and we look at my basis and it's sorted decreasingly, so B1 is the biggest number in my basis, then by taking a subset of those numbers, if I look at the first of them, your most significant bit cannot be turned off by anything later, so it will be on in XOR. And so the first, for this XOR, this XOR will consist of zeros, 1 and then whatever, and this 1 will be related to the first number taken, here B2, it has some most significant bit somewhere, and instead it's better to just take this one. Okay, proof worked. I don't even need this. I don't need basis reduction. This was a counterexample because two numbers had the same most significant bit on, and that even my strange implementation of Gaussian elimination will not create that. This is lemma, and new then how is it called? Let's say so smallest XOR Are you coding Gaussian elimination for a matrix? No. I'm choosing problems good for teaching Gaussian elimination. And I try to understand my own implementation. And this is my implementation. The block uses a nice way to implement it by iterating over the bit. No, this... I don't know if it's good to learn this method. This is more of an interesting fact. So, by the way, you will get the same size of linear basis if you do this. But it takes a lot of time to really understand what's going on here. Indeed, mine is counterintuitive. I agree. Insert vector of mask, iterate over bits. Right? This is like 20 or 30. Bit masks of length d. If this bit is on, and this bit is not yet in basis, mark it, increase the size. Else, do this. Wait, will we get the same basis? Is this the same implementation? Snapdragon says, slightly more general approach. You can do the Gram-Schmidt process and end up with orthonormal basis, which means that no two basis vectors will have a bit in the same position. What? No. That's not true that no two basis vectors. No. I think what you want to say is normally when you run Gaussian elimination, you want this to be true. This. If some basis value has most significant bit on position P, no other basis value has bit on position P. By that I mean bit equal to 1. Normally you want this. Why is this colored? These. What you said is that no two values have the same bit on, and that's impossible to achieve, and this is example. If you get values 101 and 011, by XORing them you will get... Wait. I need to make it more complicated. If you have this, then the only way you can do to change this is change them into their XOR. Their XOR is this. And no matter which number you will change into this one, two numbers have the same bit on. No, because you have some most significant bit, and let's say there is one here and some part you don't control. Let's say this is the second number. What we can do, and what normally happens and just doesn't happen in this implementation of mine, is that we use this second row to cancel the one in this first row. We have this. And generally, after we run Gaussian elimination on bits, we have this format, where there is, let's say, a 1 here. There might be some other ones. Now, a dot means 0. I think, yeah. Okay, now there is, let's say, 1 here. Here it's arbitrary number, we cannot do anything about it. Actually, let's say question marks are arbitrary numbers and we cannot do anything about them. Now, if we find a 1 here with something, then at this point we can change those to zeros. But then there is maybe this number. Now the only thing we can do is we can make this 0, this 0, this 0. Yeah, so that's the best we can do, and we can guarantee only this. And question marks are columns where no basis value has the most significant bit on that position in that column, so we cannot do anything about those. If I now XOR, let's say, this row with this one, I will mess up one of those special columns. And instead of this beautiful form, and this is what you can have, what I create is this. And now it's not that I'm only explaining to you, chat, what happens. I'm also explaining to myself. If you want to give a good lecture on something, it's good to really be able to answer all the questions. Any doubts you can have yourself. Okay. What I have, let's say my first number is this. There is arbitrary suffix. Second number is this. There is arbitrary suffix. Dots represent zeros. Dots on the left are just zeros. And now I'm not going to change this into 0, even though I could. No, that's not true. I can change, because when this is my new number x, I go through existing bases and I do XORs. So this is 0. But now what matters is if the next number is 1 and some suffix. This is already 0. Oh yeah, the thing I don't do is I don't change those things from bases above to 0. That's the difference. I could theoretically change those to zeros by adding this for loop. With reference, iterate over the bases before adding, and do this. I think that will work, because it will take a look at the most significant bit of x. So we will XOR only if it's that. Yeah, seems fine. I could do it. I'm not going to do it. And the thing is, it doesn't matter if I change those to zeros, also this way modifying the arbitrary suffix, because I XOR with those 3 question marks. But it's not needed. If later, no matter if those 2 positions, I will mark them B and A, no matter what are bits A and B, if later I have any number, maybe bigger, like this, because I always in the same order go through the bases, so this number I consider XORing it with the first number, the second number, then the third one. Then third one for sure will change this to 0. Maybe leading the fact so values A, B only can change the status of this digit 0, 1 before going to this row. So then AB might change the fact whether we XOR through this, but it doesn't matter. So it's more like, consider this fact. If a moment ago I XORed the second row by third and changed this from 1 question mark to 0, and here let's say exclamation marks, those are question marks from a moment ago XORed with this, then here just I will get exactly the same value here. That's my point. Oh, that might be an important point. Do I have exactly the same linear basis? No. But if, okay, my claim is if I did this, every next number I create is the same. That's my point. So if I here print X, then the output of this program will be the same if we XOR with this. Output of the current program is the same as the output of this program, and uncommented. But what at the end, if I want to print bases, then of course it's different, because I modified those by guaranteeing that we have zeros here. It's just that without that, I'm okay with question marks here. But every new number I'm considering will be created the same. In particular, I claim that at the end, base.back is the same, the last element of basis is the same with or without this part, because it cannot be modified. Only previous elements are modified every time. By the way, here we guarantee 0 because we are below this bit. Okay, I think I understood my own implementation looking at the chat now. The orthonormal constraint means that for any 2 basis vectors, they have an even number of ones in the same position. For any 2 basis vectors, they have an even number. I need to, likely it's not important for the whole lecture, but I'm going to understand this. So what orthonormal in linear algebra, did orthonormal mean that any 2 vectors are orthogonal to each other? That's the word, orthogonal? I need to translate. Perpendicular. Perpendicular and orthogonal are the same thing? Yes, it's okay. Orthogonal and perpendicular are the same. So, if we are in multi-dimensions, then those bits with zeros and ones, they represent just some edge going out of 0, 0, 0. In 3 dimensions, we have a cube, right? I can make a drawing for that. Mm. We have this, and now no, it's more complicated than I thought. So this vector is perpendicular to this blue vector, yeah, they are obviously. Like red is perpendicular to anything on this blue side, on this one. That's right angle, and those are 0, 0, 1 versus 1, 1, 0. Okay, orthonormal means each has unit length. Yeah, that I don't care about it. Orthogonal means that the dot product is 0. Hi, tourist. Okay, so here orthogonal just means that, yeah, what about this? 0, 1, 1, 0. Now I need to use more dimensions. If those are the beginnings, then I cannot do anything more with them. So let's say that here we'll do 1, 0, 1, 1. Their dot product is 1. I agree. The dot product of those is obviously 1. It's obviously 0. Sorry, we don't care about this anymore. This was for a drawing. But what about my two vectors on the right? Or just even this thing? Yeah, let's skip the part on the right. Their dot product is 1. And now what does it mean for me? Maybe I need to write what is what. X, Y, and Z is the depth of the drawing. Then in yellow, 0, 1, 1 is this. Up to that point. 1, 0, 1 in light green is that. They are not parallel, they are not perpendicular. Okay. And how do we create our orthogonal linear basis from this? I agree with everybody. I understand what happens with the divisibility by 2. For example, I understand that 1, 1, 0, 0, dot product 1, 1, 0, 1. This will give me 1 plus 1, so this is 0, modulo 2. Sure, they are orthogonal. Let me maybe read up on Gram-Schmidt. I remember this name from university, but that was a long time ago. In linear algebra subject, there were like tasks like apply this process, apply that process, find, I guess, orthonormal linear basis or something. The method of orthonormalizing a set of vectors, but usually Euclidean space. So we get already a basis, and we make orthogonal set out of that. But now please remind me, chat, what this has to do with what I was doing. Because I was investigating the differences between my algorithm and the standard one, where we guarantee that if I have the most significant bit here, then nothing else have them. So after sort, no. So it's just like if I took this and I said those can be in different order, of course it can be more chaotic, and then it isn't guaranteed that this is 0. Because I'm not modifying the basis. But this is for sure 0. And then, well, this doesn't have to be 0. I don't modify you. I only know that this is. I just wonder if there is any relation. What do I want to exactly say? Is there a name in linear algebra for this? Maybe that's what I need. You know, there are some names like Echelon form. What was that? Echelon form? Row echelon form. What does it mean? So it's just that my version doesn't do row echelon form. I don't like the definition of row echelon form means that Gaussian elimination has operated on the rows. Okay. Row echelon form if all rows consisting of only zeros are at the bottom. The leading coefficient, also called pivot. So I thought that by pivot we call in a column. In Gaussian elimination on real values, I thought that pivot is choosing in a column, we choose the biggest value, and then we reorder rows. Oh, so it becomes a pivot. I just thought that by pivot we mean one of elements of a column. Here they say that pivot is that most significant bit. That's called a pivot. So in real values implementation, it's just that in a column we choose such a value, in a column we choose a value to be a pivot in its row, and we choose the biggest value because that's the best real value. It's kind of like I didn't understand the grammar of what a pivot is. We don't choose pivot of a column. No, we choose not the biggest by absolute value number in a column to be a pivot in its row because it will be a good pivot. I will analyze if this is true. if we mean a name of permute the columns to make this upper triangular. But I very much care about my order of rows. So wait. Oh, permute columns. Yeah, just choose the, let's think, choose the row with the leftmost pivot, because now I learned that pivot means the leftmost thing in a row. That most significant bit is a pivot. Put that to the very beginning. We have this, and it's just that now it's kind of chaotic whether we guarantee a 0 anywhere. But indeed it's triangular. After sorting decreasingly, it is triangular form, like upper triangular, like this. And it's just that the number of extra guaranteed zeros in every column is a bit random-ish. Row reduced echelon form. I find this sentence funny. I think there is a difference between row echelon form and row reduced echelon form. Maybe. I don't know and I don't remember definitions. It's pronounced echelon. Okay, thank you. Not echelon, it's echelon. Echelon, okay. Echelon and Gaussian echelon, Gaussian elimination, matrix exponentiation. What a beautiful song I can create now. Question. Oh, I'm permuting rows. Okay, I'm stupid. Yeah. I should take this and permute columns to make this to be the first column. Okay, this will be complicated process, right? And then I think I will get a nice drawing. Let's remove the first two columns to make my task easier. And let's do this. Permute columns, not rows, to get something nice. Let's make fourth column to be the first one. Those are just IDs of columns. Maybe I should write a program for that. Won't it be convenient in Excel to swap the rows? Because I don't know how to do it in... Okay, it will be 2 minutes, so whatever. Okay, swap first and fourth. Dot means 0, so kind of whatever. Okay, right? No, this was 0. And now, for second, swap those two columns. Echelon. Oh, what did I say? I said echelon, right? With O. Echelon. Row echelon form. Why is there A at the end? Balloon. Okay. Make this to be now the second column. Dot, one question mark, dot. then this should be the third column. This, so 6 goes to this. Question mark, dot and 1, and 0, 1. And finally, let's make this to be the fourth column. You are now free. Dot dot question dot 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 1. Did we get something nice? I think we did. Every dot means a 0, so I will not lose that. The first E is stressed. Echelon. Echelon. A dot means Z. Dot means 0. Why? Why did I get 0 here? I got some randomish zeros that I don't understand, but I think it's because I just skipped something. What did I start from? This. These zeros come from dots, and I want to say that this is a 0 indeed, I guess, but it just defined the order of columns. If this was 1 and this question mark, just 2 columns would be swapped. Okay. Well, when you look at the columns in this order, you've basically done Gaussian elimination. Yep. And all of that to just analyze some very simple code, the code being this. Yeah, I think I will not show this as the best possible implementation. I will not teach that during any lecture. I will just show at the end, by the way, this works as well, but it's difficult to understand it. The code is so elegant. Yes, it is. I always use it. And it's kind of like, few years ago I understood exactly what it does, or maybe why it works, but then I just remember, yeah, it's tricky why it works, but I remember it works. I was doing something. Okay, notepads, I don't need you. Maybe this was an important problem. Find a non-empty subset with smallest XOR. Maybe good for a lecture, not really as a problem. And to existing resources, I should for sure add the blog. Algebra behind bitwise Gaussian elimination. because I took the first two lines from resources, I will also put this here. It will in the near future become redundant. You have reduced form also mentioned in the Wikipedia page. Okay, I closed it already. Wikipedia, Echelon. Each column containing a leading one has zeros in all its entries. And let's see a difference with my version after even permuting the columns. Yeah, this is a 1, and here it's not guaranteed 1. Same here. So can we say that, yeah, what I produced is row echelon form after permuting columns, or maybe before permuting columns, but it's not reduced row echelon form. Reduced would require to have zeros in the same column with the leading one. So this would need to be 0, this would need to be 0. And yes, if I add those 3 lines, it's reduced. Makes the basis reduced. So maybe makes the reduced basis is a good thing. Yeah, but I don't have exactly this because I don't care about order of columns and rows. Am I a professor? That was a strange accent. Professor. No, I'm not. I'm not. What about we continue reading the blog? Yeah. I think the first problem lacks the extra kind of harder subtask where AI is up to 500, and we need to say that then we need Gaussian elimination. After part 2, there should be kind of they should recall this problem. Yeah. This was a cool no link to the source. So this was a cool problem. Oh, I was reading this, I know. At the back of my head I remembered I was doing something, then stopped for half an hour. I was reading this. For every bit from the most significant, so find a 1. If this column is not the most significant yet, mark the column as most significant. So remember the basis of I. This basis will now have a lot of zeros, but I understand the format. Increase by 1, and if not returned, so if this wasn't else means that this was already most significant bit of something, and then we XOR. So we change this to 0. Thanks to the fact that we have here an array instead of my vector, we have kind of we sort it for free without extra logarithm, and our basis We always go through bases in decreasing order because we go from most significant bit. Now we have this return. We could also make this basis more reduced, whatever the word is, because we never change basis here. That's the thing. Let's say that this was the first vector in basis. The second one is now this. We won't XOR them, that would be stupid. Then they are sorted. So those parts are question marks. Can be arbitrary. Actually, this is also for now arbitrary. Is this guaranteed 0? If this was added first, then this is a guaranteed 0. If this was added first, so it's like this. Yeah. If this was added first, then we process this one. It's in the input, we add it. We could modify the existing base, but we don't do it. And it works thanks to the fact that we always go, this for loop goes from biggest to smallest. So it works on for the same reason why my short code works. That maybe there is something, this is an arbitrary bit, but later eventually we fix it with a 1, and then there are only zeros. Exactly. We could modify this code by modifying bases as well. And in this code we have ifs, while my code has the min of 2 values, and just min is more difficult to understand. Okay. Or smallest to biggest. No. We need to go biggest to smallest. This iterates. Oh, just for the whole time they go from least significant. Okay. So just my whole logic was always that the most significant bits are more important. For them, leading ones is the one most to the right. That's fine. It's more convenient to implement, I guess. Okay, problems, and we're done with the blog. As I said, preparing those things is so time-consuming and difficult. I think I opened this blog an hour ago. Given a set of some size with elements, find a number of distinct integers that can be represented using XOR. So just find linear basis. Is this from Code Forces? Oh no. Yeah. Markov chains and cyclic expected values. That's also what I want to teach. So I think I need to read this blog. Then we have a graph. Number of connected components. Okay, then we will understand that 0 is paired up with those, so just the number will be 2 to k divided by 2 to base size, right? Is it also Code Forces? No, Code. Oh, that's fine. If I used all of those in Codeforces Gym or Edu section, then I can easily import Codeforces problems. 2 to k divided by size of m. Size of m is 2 to size of bases. Yeah, confirmed. Maximum possible XOR of elements. The last position we have set bit. Now when you look at this code, you see why it's convenient to... Wait, will my solution work? Let me solve this problem. Oh, it's a link. Okay. In my thing, after doing this for every new item, the biggest element, is this enough for every existing in base? The idea of every leading one is that after that we only have zeros. So this way we make sure that every leading one exists in the answer, and that uniquely defines it. So my code will be just for every input number do those basically 6 lines, kind of empty, most of them, and then do this. And this shows the power of shorter code because this one is longer. I see that Abu Zada is back with interview bit problem proposal. Oh wait, this is not some random problem. This is Gaussian elimination. In row echelon form, if once you continue row operation, you have to be in continuation with row. You cannot use column. I understand that we kind of decide between rows and columns. The first look, I thought that this is some random interview problem. It is. Why are you suggesting this? It's not related to Gaussian elimination. I guess he's talking about doing the row operations like this. Yeah, but if I do operations like subtract row from the other row, it doesn't hurt to permute columns, and I can do that at any moment. Just at the end I will get a permutation of columns. Can you show me the code for Simpson integral calculation? I guess I can. Generally, I plan in the coming months, maybe a year or two, because it will take a lot of time, to publish a lot of my codes. Some of those aren't just mine. This is why I don't really want to do that. Here you go, Simpson integral. I mean, but what's the point of just copying and using something like that? Abu, do you want a timeout or ban again? Do you have an example problem where you try to find a recurrence relation for a sequence using Gaussian elimination? No, but I'm going to create one. After Gaussian elimination, I'm doing a lecture on Berlekamp-Massey, and in particular, yeah, I will make a problem on that later. Berlekamp-Massey is just faster version of Gaussian elimination to solve some specific system of equations. And obviously it's about the speed. Massey is powerful, and there are problems, including one from ICPC finals, where we need Massey, right, from 2018. It's a pity my team didn't solve that problem, because I understood Massey in my team, and we had that in our reference document. I need to go through the rest of questions. Print Kth highest number from X. Then we just need to keep that in some sorted order, and binary representation of K will give you a number you need. I like the problem. What platform is this from? Codeforces, but from a group? Just, you know, when you hover over anything, in bottom left you see a link. First Hunger Games. I remember that. It was a good, it was a nice initiative. I don't remember now. Prince of Persia did this, right? Was that all new problems? Anyway. Oh no, it's not just binary representation of K. I expected the code here to be a bit easier. Let's say that there are 32 numbers, then 16 of them, if K is from 1 to 16, let's say that K is 0 based. If K is from 0 to 15, then I want to take the biggest value. Why is this so complicated? Oh, just be... No. What is mask? Mask is the answer. Oh, because linear basis is not done yet. Huh? We go from biggest or not? Which 2018 ICPC finals? About chess and knight, there was a huge grid with height 11 and we could make moves. Oh yeah, the number of paths of some knight or something that visit every cell in a grid. And cross knights, yeah, that. That was just DP. But you don't need DP if the answer was small, and I think mainly the answer was small. You could write a recursive solution, just kind of backtrack with a lot of ifs, to make it work for small grids in complexity kind of O of number of the solutions. And after that, yeah, and you just run this slow solution for small grids. You plug the numbers into Massey, and it will quickly give you the answers for big size of the grid. You need too many values for Massey to work. Do you? I mean, the simpler the recurrence is, the better for us. Like in particular, if answers for every bigger size of the grid is just like 30, 34, 38, this is just obvious recurrence, previous plus 4. So depends on previous two values. There's a period of 50 plus, so you need to solve at least 50 times 8 boards. Oh. And 50 by 8 boards already have a lot of solutions. I was the author, by the way. I only knew that you were involved. I didn't know that you are the author. Then why did I think that this is solvable with Massey? Because I thought so. Because for some reason, I for the whole time thought that this is solvable with Massey. Maybe somebody told me that they solved it with Massey. You might have assumed that period was smaller. Maybe that was the case. For everybody, we're talking about problem uncrossed knights from ICPC 2018 finals. Okay, I believe you. If you are the author, I believe you. Then I was wrong. Sorry about that. But from time to time, there appears a problem solvable with Massey. There was one in Code Forces around a year ago. I don't know. It was problem E. Something related to starting with 0, 0 and doing some paths that don't go outside a circle, I think. And one could do a fast solution in a normal way, or one could use Massey to speed up something slower. I think organizers didn't predict that. Also in Topcoder, it happened that you could use Massey to get accepted easier. Okay, I was reading this. If we go from biggest, the very biggest value, I understand. The fact that we want to XOR with this depends on the current mask, whether the current mask of already previous bigger values from basis, whether they give us a 1 in this bit. So instead of this complicated part, I would just do this. Of course, it can be done with an if as well. And now, now for sure, mask has 0 on that special position. And it's enough to do this. So I would do this instead of that. But at least now I understand. Plenty of project Euler problems where you can shortcut them with Massey. Yeah, for sure. Massey is a very cool algorithm, but there isn't any good research on that to really understand when it will work. Basically, for, let's say, if you viewer are at least, if you know matrix exponentiation, then it's this. If problem is solvable with matrix exponentiation, then often, and the output is just a single value, then often without really doing matrices, you can compute values for small n, and they will create a special sequence where you can guess the pattern. And this is an algorithm very good at guessing this pattern. For example, this sequence has an obvious pattern of increasing by 4, or Fibonacci sequence. Like it has obvious pattern of sum of two previous values. And Berlekamp-Massey gets such a sequence of size, let's say 1000, and it guesses the simplest possible pattern. But it's not. It's kind of scientific. It's not that it guesses something. It's not that what is pattern exactly. It's well defined, called linear recurrence. I will make a video on that in coming months. This is yeah, just going from left and inserting, not even a segment tree. 6. Split array into segments. Doesn't exist a non-empty subset of segments such that the bitwise XOR of the numbers from them is equal to 0. This is equivalent to checking prefix XORs. And I solved this problem already. Maybe even I have accepted. Yeah, I have it. Matrices? What? You see my shortcode? For every b in basis, do the minimum if a pushback. So I already, well, that was a year and a half ago. I think that's not a coincidence. If you watch the stream from the very beginning, you might recognize this date, February of 2019. And yeah, this is when I created this set of problems for my students in Warsaw. 27th of February. Apparently then I was going through problems online and I solved something to check if the code works. Is this problem, what's the name? Oh yeah, because it's 0 XOR subset, so it's just this problem from my PDF. Okay. Conclusion. Oh, by the way, huge upvote. It was a very good blog. Maybe too much apologizing for terrible knowledge or something. Like also the first several paragraphs are about, oh, I'm a bit scared to write a blog. The blog was nice. Who is the author? Dr. Swat. Thank you for a good blog. Too much scrolling. Hungarian algorithm is something I never really understood what happens in cubic version. I will learn it one time. Maybe not. It's not that I will make a video. I don't have to make a video on everything, but I will once make a stream learning Hungarian algorithm in cubic time. references. Two special cases. So the first block is the one already referenced in the block. The first reference was already referenced in the block, and I even opened it with a plan to read it, because in particular it talks about expected values. This is another topic I want to require. Gaussian elimination, I think, is mainly for two things. Of course, it is to solve a system of equations, but the two main problems where you will encounter it is a graph where you move randomly and you want to compute expected value of moves. Maybe the graph isn't given explicitly, just some game. You have some state and you move randomly. Then you can use Gauss to compute the expected time to finish the game. And the second one is anything related to XOR, NIM, because that's also about XOR. And this block says exactly about those two things. Yes, I tried coding game. What's time? It's 1 p.m. I will stream for 1 more hour. Just let's make a short break now. I need to stretch. It's healthy. After a break, I will read this blog. And after reading this blog, I will get back to my list of problems and I will try to finalize it. Yeah. Full 5 minutes, please. How to find permutation of a string? I mean, you can swap any two characters and you will have a permutation of a string. You can even do nothing and string is permutation of itself. I think you don't really know what question you're asking. Prepare for Math Olympiads. Solve problems from Math Olympiads. How did you avoid use of vector in exponentiation problems? You can use arrays instead of vectors. Sorry, regarding the uncrossed knights, I see. To get from 52.7 to 2 to 18 by 7, you need to solve the recurrence. For this problem, the recurrence turns out to be very simple. What is this? The recurrence is 142 plus a of n minus 33. Okay, so by that part, I meant... Okay, now I remember too. I think already during the contest we realized that it's dp for small values and then masse. Today I didn't remember constraints, so I thought that maybe dp is unviable, and then we use some kind of backtrack to count and then masse on the top of that. Yeah. So it's indeed dp, and then we need to guess some recurrence apparently. Just basically when you see a value 10 to 18, you think matrix exponentiation or masse. But like if to solve this problem with matrices, you will have quite a big matrix, right? Like it was a knight, then you need to remember something about the previous 14 cells. So the number of states is what is possible to happen with the previous 14 states without any tricks. This matrix size maybe even is 2 to 14. For sure it's smaller. Well, apparently if the linear recurrence size is 33, then it's possible to create a matrix with this size. Okay, exactly. So the logic was we have some dp and matrix would be too big, then we use masse to just guess it, to make things faster. And unless a problem is about Gaussian elimination, I'm not going to solve it. But you know, there is a tutorial, right? Yeah, there is a tutorial here. It's not? You mean not Gaussian elimination? Yeah, then I'm not solving this today. So, you know, the thing with suggestions is that usually people suggest a problem they are struggling with instead of an interesting problem. If you are struggling with a problem, you should read the editorial and then you will learn a solution. If editorial is badly written, then maybe say about it in comments, because it's very hard to understand. Or maybe it's just too difficult for you and you don't have some knowledge. This is why it's hard to understand. I prefer to solve interesting problems or very educational. I was going to read... Did I close something important? Let me close some tabs. Okay, this problem, I think it was cool. Did I put it in GitHub? I closed the link, but I have it here in bot comments. Okay, it is here, so I can close. Xmax, it's here, close. Maybe comments say something interesting. I will go through comments, also because maybe there are some questions about common doubts about Gaussian elimination. Then we'll read this other blog, then we'll get back to my list of problems, then we'll finish the stream. We have a comment by Gupta Samarth. They discussed the name and I would just say I used some linear algebra. Also, if you type !Discord in Twitch chat, if you like what I'm doing today, for example, you should for sure join my Discord server. Just to hang out, ask some questions about streams, videos. That's for Twitch chat. For YouTube it doesn't work. If you're watching on YouTube, go to Twitch for chat. Actually, I have this stripe here at the bottom. I can turn it on. Ignore the sentence, the first sentence. It's not really very useful. See links in description for FAQ before asking question in the chat. Okay, never mind. I can set it up to show once every 10 minutes, but maybe it's a bit too late for the last hour of a stream. If values are up to 1 million, then you can brute force on the basis vector. That's a very good observation. To make it, to really require some kind of greedy going from big to small, you need to make values at least up to billion. So that 30 elements would be in linear basis, and then you cannot consider every subset of basis. Not only the comment says this is pretty well known, but I also thought about the fact that often there is some very difficult data structure and somebody from China always says, oh, it's well known under this name in China. I don't know if this is a guy from China, it's just that maybe he's just judging from profile picture. Everything is well known in China. What's the point in writing such a blog, right? Actually, China has a nice thing in their programming camp. I think it's part of their IOI selection. That they have some camp and each person needs to write, in Chinese, write a paper about some algorithm. And this is, for example, how I think one person discovered segment 3 bits. Discovered / came up with. the thing with kind of smart lazy propagation for maximum and for minimum element and maximizing with something. This was included. For arbitrary large dimensions of D, this algorithm actually works in ND square, correct? Here we assume that XOR can be performed in O of 1, but it is not generally the case. I'd say this. Would using bit sets help? I will upvote this block because it's a good doubt to have. I will even answer. It's just that the even with a billion, I bet you could get away with a recursion where you try all odd combinations of basis vectors with the highest bit set, then recurse. What? A typo? Yeah, sure. Even Grammarly corrects me. I mean, 2 to 30 maybe divided by 2 or 4. It will take like 3 seconds. Already +2, good. Add color problem A. Oh yeah, that was very recent. Why? The page. Half the pages take 10 seconds for me to load. I don't see any issues with a stream. I have some statistics on the second monitor, like everything is fine with the connection. So why does it take so much time to load? Like now add coder, previously some other site. Something wrong with settings of my internet connection? I bet that here in standings I will not be in the top, but at least my submission for A will be in the top. Yeah, like 4th fastest. Why did I solve only A? If this was a Codeforces contest, I would say that I apparently needed to go somewhere. Maybe after 10 minutes, it turned out that I needed to quit. In AdCoder, it might be the case that I just couldn't solve anything else. AdCoder is crazy. So I had 4th fastest time in A, and then I solved nothing more. Nice. And the solution for sure is exactly the same code. Oh, no. Cannot. My submissions. X is mean of X and number from base. If I insert 7 and 3, yeah, sure. Why is this downvoted? Maybe I shouldn't be that quick to upvote, because then you cannot encode forces cancel this if I realize that it's wrong. Sure, it is correct here. It's not correct. This should be 0, 1, 0. Well, right? Am I right that just... Oh, now I understand his question. Okay. I should think more instead of rush. But they go from right to left, so for them this is the... Yeah, I think he's right. Because the algorithm... Where is the code? We go from least significant bits. So we will mark something as basis already for 1, 1, 1. Then for 3 we will XOR with that other number and we will get 4. So he is right. Is it correct now? Okay, I've read the comments. That's, always good to know what people have doubts with, what is difficult in something. To then, especially if then I want to myself create such an article. The second block. After that, we get back to my list of problems. So this one links to CP algorithms for just general explanation of an algorithm, and it describes the bits version and Markov chains to compute expected value. I wonder if this is a scary sentence for people who are not good with expected value. Many times as a part of expected value problems, you are expected to Sum up infinite series that hold as limits as probabilities lying in the closed interval 0, 1. I'm sure that this sentence scared some people. This is unnecessary introduction. It will only scare people. If somebody understands all of that, then likely they already know the technique. This is exactly my problem of moving randomly. Oh, here it's a tree. For a tree, likely there exists some other solution. Maybe if that's a tree, then precision errors are less of an issue. What can be the worst possible answer? If you're given a tree, you start in vertex 1, you want to end in vertex n, then how many steps on average it will take you? I guess that I can make a star, then a line. In a star, it will take me n/2 steps on average to get out of the star. Then when I'm on a line, I have probability 1/n/2 to get to the end, otherwise I get back to the star. So I think that then answer is n square for star with a huge line going out of it. If it's just a line, it's called Gambler's Ruin. You can read about it if you want. It's this. And it's nice because in a graph you can make answer is exponential of the number of vertices. And then I guess that in a tree it is just yeah, I think in a tree it's just polynomial. I would guess n square is the limit. But maybe you can create something more complicated than star with a chain, and then it will be bigger. I don't know. Yeah, so doing this doesn't require any understanding any of that. But if you're here, then you make one step and then you're in some cells, each with some probability. This is scary. Is it important that it's... Wait, what? Invert the matrix using elimination, augmenting with the RHS. What is RHS? Right hand side. Okay. Sure. I saw the comment in the chat a second after I googled it. So what is required for a matrix to be invertible? Is it about non-zero determinant? Yes, non-zero determinant. by why does it matter? So this means basically he wants to say that there is one solution, because a square matrix, wait, is it true? Square matrix with non-zero determinant has exactly one solution. True or not? In reals, non-zero determinant means it's invertible. Okay, true. Then he says invert the matrix using elimination, augmenting with the RH right-hand side to obtain the answers. And that's because applying Gaussian elimination is basically the same as inverting the matrix. It's more that I thought that Gaussian elimination is a tool we use if we want to invert the matrix. It's more like to invert a matrix, I think we create a new matrix on the right, we put ones on the main diagonal, and we now run Gaussian elimination of this huge thing of size n by 2n. Wasn't that how we invert? But so this is, do we add one column or n columns? And isn't that overcomplicated? As long as you don't, right, every row is an equation. So as long as you don't permute columns, I would just call it, we run Gaussian elimination and we read the answers starting from kind of, if it's in those best standardized form, then we start from the bottom to read the answers. Okay, make identity matrix on the right side, exactly. So this is not a single column, it's just the whole main diagonal. Okay, but isn't this only more complicated than we solve a system of equations? To solve a system of equations, we don't need to invert a matrix. Why do we invert a matrix? I will show you how I do it. Let's say that this is a directed graph. This is the end. So let's say that they are numbered, those are variables, x, y, and z. And I know that if I start at z, then expected time to finish is 0. For y, it's there's 50-50 probability of going to x and going to z. So it's one step plus half times x plus half times z. For x, it's just one step plus we are at y. Now we solve this system of equations. Of course, you can write it in some better form, because every column, I say there is column for x, for y, and z. So the first one is, and for the constant. So the first equation just means Control Z doesn't work. 1 times 0 is equal 0. Then second one is half of x minus 1 half. I just moved y to the right. Why Control Z doesn't work? Oh, now it works. And here, do I put this with minus or not? Let's say that no. So this reads, this row means half of x minus y plus half of z plus 1 is equal 0. Then that's the last one. Okay, there are zeros. Now this is my matrix. And I do Gauss. At the end, I will do something. I will get something like this. Well, obviously, this row is easy to solve, but in general, I can permute rows. It doesn't hurt. Just don't permute columns. if I get at the end this means that actually those will be with minuses because this is how I created them. Here x is 7, y is 1.5, z is minus 1. Sorry, z is 0. Now, did I invert a matrix? I don't want to simulate the whole Gaussian elimination, but I say from the first one, run Gaussian elimination to also get zeros in here above the main diagonal, and we have what we need. Why did he say invert a matrix? Hello, Marco Dev. Can we? We can use any prime mod 2 to obtain expected value in modulo. I think there is an issue. No, so we'll see. The fact that I get ones here is basically inverting. Okay. I see. So just I don't think about it as inverting a matrix, and it's possible to do everything without understanding what is inverting a matrix, but we're fine. Yes, programming mouse, it's correct. How about QR decomposition? I don't know what is QR decomposition. The decomposition into squares? And indeed, Xaos in the chat. I think that this block so far is bad. Sorry to the author. What about now XORs? And this one doesn't explain at all, I think, for modulo 2. Okay, this block is, I think, useless for me. How much does fuel cost? You can check. It's more expensive than making a sandwich yourself, but it's less expensive than ordering food. It's LU decomposition. Now we will, for 5 minutes, we will keep guessing what Xalos meant with QR decomposition. I think I got a book. Chat, you can guess what book I ordered. It's something I for a long time wanted to read. I only read in the internet some small parts. Competitive Programming 4. No. Game of Thrones. No, it's programming related. I've read the first Game of Thrones book a long time ago, and it wasn't the best. It was too long, so I didn't read some Knuf book. No, it's you're thinking too high of me. It's not competitive programming, but it's programming. At least I think it's that book. It's a very, very well-known book in the world. I'm sure it sold more than Knuf or something like that. What am I looking at? I'm looking at the good block. The good block mentions some more blocks at the bottom. So this one I don't like. General ideas. This is a list of like 15 things. And I guess, yeah, XOR subsets. I'm surprised that nobody guessed yet, because I said the name of this book for sure tens of times. This is the package, by the way. The unboxing. I thought that this will be a link to a problem. Helpful comments for problem 6. Okay, that's just solution of a problem. And solution idea using this trick. Okay, I mentioned this solution where this won't change more than 30 times as you process the prefixes. It's this thing, when we start somewhere, the number of different basis sizes is limited. Might be a bit loud for you, and I might need scissors. Rip ears, sorry. Do you recognize it now by color? Okay, I'm done with blocks. Now I will move to my list of problems. Yes, cracking the coding interview, 6th edition. What a beautiful unboxing we had here. The book is a bit destroyed, like there is humidity at the bottom. I'm not going to give good review to this shop. Anyway, I will have something to read before sleep now, every evening. Close, but it's a good block. Let's get back here. Obviously, this book isn't for me to learn something, to learn a new algorithm. It's for me to see what is this most popular book for coding interviews. Because, well, now, today I'm doing something for competitive programming, this Gaussian elimination, but sometimes also I'm involved in coding interview teaching. Now you can go work for Google, yay, hooray. I mean, not now, after I read the book, then I maybe can get to Google. No. I'm learning today Gaussian elimination, like with so many details, to pass the interviews. Yes, Ellipse is right. It's to learn how we learn so he can teach us better. Exactly. I learn to teach. I learn how to teach. I spent a lot of time reading different articles that I already know a topic. Solve a system of n equations and n variables. There is exactly one solution, print the solution. Cool. Solve a system of equations and variables, say 0, 1 or infinity. What about maybe to decrease the number of problems, what about making already this modulo? Because in those real value related problems like expected value, we assume that there is exactly one solution. So let's remove the second problem, and in the third one we will require saying if there are 0, 1 or infinitely many solutions. Sounds nice? Will I review the book? Yes, maybe I will. You know, just talking and bullshitting in English isn't my strong suit. Why internet so slow? I click edit and I need to wait 10 seconds. Is GitHub down? Or what? With me or... Oh, damn it. I don't know. I don't really want information if it's up, but does it take 5 seconds to load for everybody? Something is weird for sure, but is it the same for you? Yeah, it won't be inf, just more than one. We can even ask about the count of those and it will always be modulo to some power. It will be mod power number of variables minus the basis size. Will I make the contest for this as well? Yes. I don't know if it will be in edu section or in Code Forces Dream. Okay, so I'm removing this. Modulo P. Say if there are 0, 1 or many solutions. So those are two main educational problems. What about the third one? And the third one, let's say that we require fast operations. Compute size of linear basis of given n number of length m each. And now I'm thinking about limits. If it's this, then it will pass if you do it in nm square. And everybody will do XOR. I wonder if I should require bit sets. It's stupid, it's language dependent, so maybe better not. What if I do it like that? I think now I really require n times m, or just nm squared divided by 32. Do we have a simple Code Forces problem about XOR of numbers? Sum of XOR, no. Okay, then should the statement say exactly this, or should the statement say compute the number of possible XORs? CSES is a good problem set. Maybe they have something for this. XOR. Maximum XOR subbar, I know. This will be try. Yeah, it's try. Gauss subset. Anybody knows? Is there CSES problem for this? XORs, subsets. Okay. Will Python be fast enough? Python might be too slow. Okay. Those, I think, are good first three problems, just to go through them carefully. And it's like kind of, let's call it state of the art for Gaussian elimination. You need to be able to do those three things. Modulo P, bitwise Gaussian elimination, and real values. What should be the order of those? I think that mainly we need to learn this, the real value thing, even though implementation of XORs is easier at the end. Some of the problems look like linear programming problem, but can be solved using dynamic programming. Any thoughts on this? For basically anything, it's about if you solved tens of problems of some type, you're just getting better and better in understanding, in seeing what category of a problem this is. Gaussian elimination problems, some difficulties. Four hours already. I will finish in a moment. Indeed, I streamed for more than 4 hours. I wanted to do 4 hours. I wanted to finish 5 minutes ago. I'm annoyed by this thing in the book. I will show you to the camera how it looks like. So in the bottom, you see it's a bit destroyed by, I think it's humidity. Or maybe not. If not, then just somebody hit it. I derailed him by giving that block. Were you the one, Gupta, who provided the good block about bitwise operations? Then, well, it was good to see. What's up with my internet? Why? Maybe my internet wants to tell me that I should stop the stream. I will maybe put this as to do. This is not up to date. Oh no, because the first three problems are the educational ones, and then everything is about using something that we already learned. And those three must be done from scratch. I'm not going through those today. Seems like you could cover mod p, Gaussian elimination first, which is easier than add pivoting for the floating point version. You know what? For us it's easier, but if somebody writes a solution for the very first time, don't you think that modulo p is harder to debug? Maybe... If something doesn't work for you, modulo p, and p is billion 7, and you will divide stupidly, you will do something in a stupid way, you will get a matrix with randomish values. This is the first thing. The second, some people don't know modulo operations. In particular, in high school, some people in high school, they will learn already this, and they don't know what ZP is. They don't know in modular inverse. So while if I was explaining to somebody experienced in competitive programming already, and I know that they solved tens of problems for modulo p, then I would talk about this one first. The first problem has its own disadvantages as well, because we need to check if something is 0. And that's very annoying. You need to do if this value, absolute value of this, is greater than epsilon. Only then this is non-zero. But if I give limits small enough, then this way, but even not telling participants about it, I can make sure that they don't have precision errors, as long as they use epsilon to compare with 0. And I find this kind of decisions very time consuming, because not only I now during this stream do that, but later, I think this is called cognitive load. Refers to the used amount of working memory resources. Maybe it's not exactly that, but might be related. I do other things, or just even I take a shower and then I think, which of those two problems is better to put first? And you can decide about it in 5 seconds, because we can say, oh, okay, this goes first. But the same was for matrix exponentiation. I spent too many hours choosing problems. That's decision fatigue. Is that scientific term? But yes, sounds good as well. So maybe there are two aspects here. One is that I need to decide. But the other, it's not really just about deciding, it's just about also polishing and thinking about the content too much to think what we need to do and say. Anyway, I will, as I said, I will get back to thinking about this like in the evening or something when falling asleep. XOR maximization. Okay, what about minimization? Is it a good problem to give? I don't think so, because too many people will submit it without understanding what they did. But yeah, I can make two problems for minimization and maximization. Oh, I remember what I need to ask Mike about. How does it look in edu section now? I need to check. Do you see, if you submit in edu section, do you see test where you get wrong answer? Because if we go to gym and this metric exponentiation, we choose, wait, I'm not logged in. Why cannot I modify it? Enable coach mode. edit. There are some options here for contests in dreams, and in particular, I think it's not available here at all. Oh yeah, there are some options like do not show tests. Yeah, this thing. I couldn't, when creating a public dream contest, choose options to show tests. How that? Anybody here in the chat participated in Codeverse's edu section? How does it work? Should I just go to something? Submit? Also, I heard the complaint that arrows don't work. Oh, they do. Try submitting. Yeah, let's just submit. Binary search. I want a problem with one thing in the output. Like whatever. I want to get accepted on the sample test. Let me know if I'm getting any compilation error. Four, 1, 6. 1, 3, 4, 1, 6. Will this compile? What's the issue? You can view lectures. Which topic? I want to understand if I see the test. I strongly prefer an option to show a test. Okay, we show a test here. So in terms of this displaying tests policy, edu is better than Gym. In Gym, I couldn't set it up like this. It's not that when you learn something new, you should deal with just getting wrong answer as if it was during the contest. Any disadvantages of this edu compared to Gym? I hit space because I thought it will scroll me down. Maybe I would prefer this to be just YouTube plugin. Because, you know, I also want those videos to be on my YouTube channel. We'll see. I will talk with Mike. Why don't you go through IOI 2020 problems? I cannot do 10 things at the same time. Stop asking me why don't you do this. Did I say I will never do it? I will likely one day make virtual participation of IOI. Just today I wanted to do something else. Okay, I'm not going through this today. My list of problems. And I'm assuming that this goes to edu section. Those will be 3 new problems. This is from Spoy, and the statement is so simple that it's not really that we get the idea. What's up with the internet? It's not really that the idea of maximizing XOR of subset comes from Spoy. So I think we can steal it, and it will not be called stealing, because it's just a well-known thing, for sure mentioned in the blogs. So this can be turned into a problem. Then this is a completely new problem, also needs to be done. So we have 5 already. This will be just a link to spoil this. Yeah, because it just describes this technique. Then there are more things about XORs, like all of this is about XOR, all of that. Yeah. 0 XOR subset, less. The one about prefix XORs, it's not extremely cool, but it's fine. Topcoder problem, I think, had a very long statement. I'm connected via wires, don't know. Okay. This topcoder problem was extremely long, but should I make those 2 problems into Codeforces problems or not? It's something about nim. Alice removes some numbers so that no subset of remaining numbers would have XOR 0. So it just needs to leave some basis. Okay, so this we need to print n minus basis size. So that's very easy. This is equally easy as this. When they have prices, now this is more about greedy thing. Maybe just good to say that this is one problem. But this is, by the way, my own invention. Where we have prices of every number. This is equivalent to what? Find basis consisting of numbers with maximum total sum of values of prices. I think this should be one problem. And even the statement could say, if all prices were equal 0, the answer would be equal to n minus size of linear basis. This should be a subtask. I don't know if Codeforces Edu supports subtasks. Then Ivan and burgers. Oh, this is a more difficult problem about segment tree or this pointers thing. Yeah, that's very important. Sum of XOR. This is the one somebody suggested today and I liked it. Because this is a non-trivial case of making a system of equations from a problem. While so far either it's obvious what's the system of equations or we just operate with binary numbers. Out of context question, how would you explain dp to f4 you wrote? Here you go. If I tell you to compute this, after 5 seconds you will tell me that this is 7, right? And now, after you know that this is 7, and you used 5 seconds for that, what's this number? Now, if you give a class even to small children, everybody will quickly say that this is 8. And for some reason they computed this more quickly than the previous number. So that's the p. You reuse the same value. You compute values one by one. This is a huge simplification. The p is more complicated, but this is the only thing, the only way how you can explain it to a 4-year-old. I think it's a very nice comparison. Yeah. But you know, it's not that I came up with this analogy. the whole point of my streams and of reading, for example, this cracking the code interview is just to see how 100 other people explain the different things in algorithms. And yeah, my DP lectures, they have a lot of new things that I didn't copy from anybody else. Those were my ideas. This thing I told you now, I saw it in the internet, this analogy. Just reuse the values. So if you will keep being asked about the sum of some number of values, you reuse kind of some smaller value, shorter string. Okay, so I said this is cool, I want this. This is continuation, like harder version of Ivan and Burgers. Maybe the order should be different. Should I swap those? Then there's this hard problem, and those I'm not checking out today. Good artist copy, great artist steal. Maybe. I wanted to make Gupta my mod. Let me do that now. We agreed on that a few days ago on Discord. I don't see such an option. How do you do that? /mod. Okay, Gupta, you're a moderator. You can now do those things yourself. Any more suggestions, chat? Is this a good set of problems? Where this, if possible, it will be like a problem with a subtask. I care more about the second problem. How many problems do we need to prepare? 1, let's say 2, 3, 4, 5, 6, 7. There will be 7 new unique problems. Related to this, starting vertex, it's also important that in some problems it can be done linearly without Gauss. You remember example of that from some Olympiad, I think it was Japanese Olympiad. I need to write it down. If the graph has special structure, we can do this faster. Examples: moving forward by 1 or getting back, or the Japanese problem. Maybe somebody from the chat remembers it. Expected value or recurrence relation. I don't want to here show the full recurrence relation thing. Like to guess the recurrence relation instead of using Berlekamp massing. I will do that later when I cover massing. Expected value, I have that. Now I will make a drawing and you tell me, chat, if from where this is. There was a problem where we have balls of different colors, and every move we recolor a ball into a random color, random other color, and we want to find the expected time when we finish. Does anybody remember the source? It was from around 3 months ago? Maybe half a year ago? Might be from... I don't recently participate in ICPC, so maybe Google Code Jam stage, maybe some Olympiad training. Because I remember that I know it, I think, if it is about a problem solved. Yes, I solved it during a stream, I think. The solution involved a graph looking like this, like a ladder. So what's the source? This is how the graph looked like. And edges are directed. If needed, I will ask it on code forces, and then remove a block once somebody answers me. Examples moving forward by one. Yeah, this moving forward by one is this problem, but there was some code forces discussion on this problem as well, where there are stages of video game, and let's say at every moment you either move forward by one or you get to one random of previous stages, let's say. This can be done in linear time. HackerF? No. I didn't solve any HackerF problem recently. No, not with the colors. Okay. Yeah, so I will ask my friends about it. Maybe somebody remembers the source. Don't think it was Google Code Jam. Then Facebook Hacker Cup, I would remember if it was from one of these rounds. It was from this year, so it wasn't previous Google Code Jam. I mean that one from a year ago. Okay, I think some Olympiad. Anyway, we're getting at 4 hours and a half, so let's finish the stream. I'm happy with my new knowledge and my list of problems. CodeChef, I see that you just suggest different platforms. It's not that it will help me too much. I need an exact link to show people that problem. Though this problem with ladders and colors, it was very difficult. Okay, last thing, I will read this just to have something to think about. And the other thing is, it's bad to give people 20 problems on the same topic, because it's bad to practice one topic for such a long time, because you have a huge hint that you need to use Gaussian elimination. It's better after learning a topic to get back to solving random problems, because it's very important in competitive programming to get a skill of understanding what you should try, not really always seeing a tag. Oh, this is Gaussian elimination, divide and conquer, so I will use this and that. There is a grid. Probability of ball hitting any particular target. There is a tall rectangle. Targets. From the top, Collisions with pegs. A peg is just empty or what? I think this may help and link to drawing a graph. I don't think it will help. I don't understand a work peg here. I see that ball gets from the very top, and then when X happens, then it gets to random neighbor. But I'm guessing that we need to go from row to row instead of getting the whole. One solution would be get the whole grid and find the expected value. Right. Oh, from any open space. Yeah, this is what I needed. When you are in open space, you have some probabilities of going in every direction. What if we go outside of the grid? You can safely assume that this By the way, this is not enough. The grid might be disjoint, and I don't know how program will behave if expected value of time starting from some cell will be huge, then maybe also some probability will be very small but close to zero, and you can get time limit exceeded with long doubles. I will put it, that's an important thing. Say something like okay, so if grid is huge because it has size 200,000, we for sure cannot run Gaussian elimination on the whole thing. But when we have the first row, we need to move in some way to the second row. We can compute probabilities of, if we are in first row, I will need this. For every cell in the second row, what's the probability of getting there? But also, if I ever go back, the problem is easy if we just move left, right, down. If we ever go back, I need to also know answers, like probability of hitting stuff above and probability of getting back below. So a reasonable polynomial solution will be this, and it's just about improving it to proper complexity. When we consider this border between two consecutive rows, for every, I need to know probability from the start because I start at the top. Start here. First thing is for each of those, probability that we cross it after we start at the top, that we cross this for the first time. That's the first thing. The second one is if we go back like this or like this, then we need to know probability of what happens. And this consists of two parts. The first is Pij. if we start from I, what's the probability that we will travel some path and finish at J? That's one. The second is that maybe we go up and then we finish somewhere in the top. So this is more like probability of winning, starting from this I and getting somewhere here. And either we pass this as we move down, or the down part will return to us what's the probability, or more like expected value, of times we cross some position. No teams solved this in 2014. Then this is a difficult problem. A lot depends also on the other problems in the problem set and about the leaderboard. Sometimes it's just about coincidence. A team will solve another problem, then everybody else will follow that. They will not even solve this. But if nobody solved something in the finals, it means it's a difficult problem. No question about it. I'm not going to try to solve it now, just thinking about it. I think that's enough for me today. Let me do two things. First, if you found the stream interesting, check out Discord server, link in the description, and also here in Twitch chat. The second is, I'm not really regular now with Twitch streams, but if you want to rewatch any old stream, they are on my YouTube second channel, link in the description, Errichto 2 on YouTube. And my schedule, no, not this. My schedule most of the times is just on Codeforces. So the next thing is Monday. I thought for a moment that maybe on Sunday or Saturday I will face Steven, the 1v1 lockout thing, but maybe not this weekend. This weekend is busy. Yep. And that's it. So and there are also pings about streams on Discord, so you can follow me there. I mean, join the server and there will be notifications. Yeah, that's it. Thank you everybody for watching. I hope you learned something together with me. Thank you for everybody commenting and helping me with some links to problems, to blogs, finding mistakes in what I'm saying stupidly. And see you next time, most likely on Monday, same time. I don't know what I will do then. Bye bye.